10th class, third chapter, exercise 3.1. Here, the first question is form the linear pair of equations in the following problems and find their solutions graphically. So here, in it, the first question is 10 students of class 10 took a part in a mathematical quiz. If the number of girls is 4 more than the number of boys, find the number of boys and the girls who took part in the quiz. Here, if you observe the total students, solution, the total students are 10 members. Here, let number of girls I am taking as X and a number of boys I am taking as a Y. From the question, we can write the total students X plus Y is equal to 10, and also given that the number of girls is 4 more than the number of boys. For example, that means if we subtract boys from the girls, that means X minus Y, we get 4. This is, wait, we can write it as a Y is equal to 10 minus X. Here, Y is equal to X minus 4. So, these are the two equations what we need. From this, we can draw a graphical representation. Here, we have to draw a table form X, Y. If X is equal to 4, Y is equal to 6. If X is equal to, this is for 1. If X is equal to 5, Y is equal to 5. If X is equal to 2, 10 minus 2, 8. Then Y gives you 8. If X is equal to 0, Y is equal to 10. This is the tabular form. Similarly, we have to draw a tabular form to the second equation also. So Y is equal to X minus 4. X, Y. If X is equal to 1, Y is equal to minus 3. If X is equal to 2, Y is equal to minus 2. If X is equal to 5, Y is equal to 1. If X is equal to 10, Y is equal to 6. So, in this way, we can find any tabular form. So, now we are going to draw a graph here. I am taking X as a 2 units and Y as the 2 units as a scale. So this is a 0. This is an X. This is an X dash, this is a Y, this is a Y dash. So this is a positive 2, 4, 6, 8, 10, 12. Here also positive 2, 4, 6, 8, 10. Here negative minus 2, minus 4, minus 6, minus 8, minus 10. Here also negative minus 2, minus 4, minus 6, minus 8, -10 and -12. So now we have to represent these equations on graph. So first of all, x is equal to 4, y is equal to 6. Here x coordinate is a 4, y coordinate is a 6. Here x is equal to 5, y is also 5. So 5 it means it is in between 4 and 6. This is. Here x is equal to 2, y is equal to 8. Here x is equal to 0, y is equal to 10. So you can draw a straight line by combining these points by using the scale. This is y is equal to 10 minus x. Now represent this equation also on the graph. X is equal to 1, x1 here, and y is equal to -3, -3 is here. Now x is equal to 2, y is equal to -2. Now x is equal to 5, y is equal to 1 here. When x is equal to 10, y is equal to 6. So here you have to draw a straight line. If you use graph, you get exactly pattern. Here this is a 7 and this is a 3. The coordinate points x is a 7 and y is a 3. So the number of x is nothing but number of girls is equal to 7 and boys y is nothing but number of boys there are 3 members. So this is the way to represent the graphs and equations on graphs to find out the interaction point or intersecting point on a graph. Similarly, so in first question, second one is 5 pencils and 7 pens together cost 50 rupees, whereas 7 pencils and 5 pens together cost 46 rupees. Find the cost of one pencil and that one pen. Here, first of all, solution. Let cost of pencil is equal to x and cost of pen is equal to y. So here given that first condition 5x plus 7y is equal to 50. From it you can write 7y is equal to 50 minus 5x, y is equal to 50 minus 5x by 7. This is condition 1 and condition 2. 7 pencils, that means 7x plus 5 pencils. So 5y is equal to how much cost? 46 rupees cost. So here 5y is equal to 46 minus 7x, y is equal to 46 minus 7x by 5. So this is the second equation. So we have to draw tabular forms to both the equations x, y. Here also x, y. So I am doing rough work there. If x is equal to 3, then y is equal to 15 minus 5 into 3 by 7. Y is equal to 15 minus 3 5 5 3 is 15 by 7, that is equal to 15 minus 15 35 by 7, 7 ones are 7 5s are. The answer is y is equal to, we get 5 here. Similarly, if you take x is equal to, similarly we take x is equal to 10, then y is equal to 50 minus 5 into 10, that gives you by 7, that gives you 50 minus 50 by 7, that is equal to 0 by 7. 0 by 7 we get 0. And now if you take minus 4 as a x, then y is equal to 50 minus 5 into minus 4 by 7. So 50 plus of minus plus 5 4s are 20 by 7. So 50 plus 20, 70 by 7. You get that's 10 as a y. So similarly, we have to find this tabular form also. Now the it. Next, y is equal to 46 minus 7x by 5. If I take x is equal to 3, then y is equal to 46 minus 7 into 3 by 5. So 46 minus 7 3s are 21 by 5. So 46 minus 21, how much? 46 minus 21, 5 to 25, we get 25. So y is equal to 25 by 5, 5 ones are 5 5s are. So we get y as a 5. And if you take x is equal to 8, so y is equal to 46 minus 7 into 8 by 5. 46 minus 7 8s are 56 by 5. You get minus 10 by 5. That means minus 2. So here y value is minus 2. Now if you take x as the minus 2, y is equal to 46 minus 7 into minus 2 by 5. So 46 minus of minus plus 7 2s are 14 by 5. If you add it, you get 60 by 5. 5 ones are 5 12s are. So y is equal to 12. These are the tabular forms. Now you can draw graph to these equations. First of all, we have x-axis and y-axis. This is x, this is x dash, this is y, this is y dash. 0, I am taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have negatives 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also positives 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here negatives 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Minus 11, minus 12. So here, first of all, x coordinate is 3. So we take here, and y coordinate is 5. So the coordinate points exist here. And then x coordinate is 10. And y coordinate is 0. That means the point exists here. Yeah. And here x coordinate is minus 4 and y coordinate is 10. The point exists here. If you draw a straight line, it goes in this way. This straight line. And represents the second equation also in the graph. So x coordinate is 3 and y coordinate is 5. that means same point. X coordinate is 8 and y coordinate is -2, that means here it exists. And x coordinate is -2, y coordinate is 12, here it exists here. So here this is the point what we needed. So here the point is 3, 5. So this is x, this is y. So here x is nothing but the cost of the pencil. X is equal to 3 and the cost of pen y is equal to 5. That's it. Exercise 3.1, question number 2. On comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the lines representing the following pairs of linear equations intersect at a point or parallel or coincident. So here given pair of linear equations, we have to find out whether these equations are intersect at a point or parallel or coincident. So here first of all, a1 is equal to 5, b1 is equal to -4, c1 is equal to 8, and here a2 is equal to 7, b2 is equal to 6 and c2 is equal to -9. We have to find out a1 by a2, that is equal to 5 by 7. This is the simplest form. Now b1 by b2, that means -4 by 6. So here if you cancel 2 2s are 2 3s, you get -2 by 3. So if you observe clearly, a1 by a2 is not equal to b1 by b2. So we can say that the given lines are intersecting lines. And they have only one solution. They have only one solution. So similarly, here also a1 is equal to 9, b1 is equal to 3, c1 is equal to 12, and a2 is equal to 18, b2 is equal to 6, and c2 is equal to 24. a1 by a2 is equal to 9 by 18, 9 1s are 9 2s are, you get 1 by 2, and b1 by b2 is equal to 3 by 6, 3 1s are 3 2s are, that is equal to 1 by 2. Very good. Now c1 by c2, 12 by 24, 12 1s are 12 2s are, that is equal to 1 by 2. If you observe, you get same answer. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So all ratios are equal. So we can say the given lines are coincident. And they have many solutions. Similarly, for the third question, here a1 is equal to 6, b1 is equal to -3, c1 is equal to 10. Here a2 is equal to 2, b2 is equal to -1, and c2 is equal to 9. a1 by a2 is equal to 6 by 2, 2 1s are 2 3s are, that is equal to 3, and b1 by b2 is equal to -3 by -1, so you get answer 3, and c1 by c2 is equal to 10 by 9. This is the simplest form. So all are not equal here. a1 by a2 is equal to b1 by b2 and that not equal to C1 by C2. So we can say that the given lines are parallel lines and they have no solution. From these questions we can say that if the ratios A1 by A2 is equal to B1 by B2 is equal to C1 by C2, all ratios are equal, then we can say that those two lines are the coincident lines. If A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then we can say that the lines are parallel lines and they have no solution, and these coincident lines have many solutions. If A1 by A2 is not equal to B1 by B2, we can say that those lines are intersecting lines and it has only one solution. That's it. Exercise 3.3, question number 3. On comparing the ratios A1 by A2, B1 by B2 and C1 by C2, find out whether the following pairs of linear equations are consistent or inconsistent. So how can we say the given lines are consistent and inconsistent? If the given equations has the solution, then we can say those lines are consistent. They have no solution, we can say that those lines are inconsistent. So here we have to find first of all they all have solutions or not. So first one, A1 by A2 is equal to 3 by 2 and B1 by B2 is equal to 2 by minus 3. So clearly here we can say that A1 by A2 is not equal to B1 by B2. So these lines are called intersecting lines. So intersecting lines have one unique solution. So it has unique solution. So these are all consistent. Similarly, second one, A1 by A2 is equal to 2 by 4, that is equal to 1 by 2. So 2 ones are 2 2s are. So B1 by B2 is equal to minus 3 by minus 6. Minus minus cancel, 3 ones are 3 2s are, you get 1 by 2. C1 by C2 is equal to 8 by 9. So if you observe, you can't cancel it. So A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. We can say these lines are parallel lines. So parallel lines. So no solution. These are inconsistent. Lines, inconsistent lines. Next one, third one, A1 by A2 is equal to 3 by 2 divided by 9 by 1. That means 3 by 2 into 1 by 9. So 3 by 2 into 9, 3 1s are, 3 2s are, sorry, 3 3s are, 2 3s are 6, 1 by 6. So A1 by A2 is equal to 1 by 6. Now B1 by B2 is equal to 5 by 3 divided by minus 10 by 1. So here if you observe 5 by 3 into 1 by 10, 5 1s are, 5 2s are, that is equal to 1 1s are 1, 3 2s are 6. So here also you get the same answer. Now C1 by C2, here minus 7 by minus 14, minus minus cancel, 7 1s are 7 2s are, you get 1 by 2. So here A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. So here also say these lines are the parallel lines and no solution and no solutions. So these lines are called inconsistent lines. So now fourth one. So here a1 by a2 is equal to 5 by minus 10. You get to minus 1 by 2. So because 5 1 is 5 2. Next to b1 by b2 is equal to minus 3 by 6. You get 3 1s are 3 1s, that is equal to minus 1 by 2. Now c1 by c2 is equal to 11 by minus 22. Here also you get minus 1 by 2. So if you observe, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So here these lines are called coincident lines. These lines are called coincident lines. And it has many solutions. It has many solutions. So we can say that these lines are called consistent. These are called consistent. So those are called consistent. These are inconsistent. This is inconsistent, and these are also consistent. Now we are going to check it to solve it and the bigger this problem to understand. Now here a1 by a2 is equal to 4 by 3 divided by 2 by 1. That means 4 by 3 into 1 by 2. 2 1s are 2 2s are. So a1 by a2 is equal to 2 by 3. b1 by b2 is equal to, again here already given, b1 is a 2 and b2 is a 3. So same answer. Now c1 by c2 is equal to 8 by 12. So 4 2s are 8, 4 3s are 12. So you get the same 2 by 3. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So these lines are called coincident lines. These are coincident. So it has many solutions. It has many solutions. So these are called consistent lines. That's it.